Hi, in this video we will learn about the notion of rate of change. Well, assume that we have a function, let f be a function on a real line. Well, it can be only on an interval, that's enough for us. And well, this function can be, for example, a price of a property in London, Ontario. It can be a position of an item moving on a straight line. And most of the time we find the study of the change of the values of functions very useful. In the case of the price, for example, you want to see how the price of the property change on the time interval AB. Well, so then you find the price of the property at the end of that time interval minus the price of that at the beginning of that. This is called net change of f on that interval. But without considering the length of the time that this change occurred, we are missing a lot of information. That's why we sometimes like to study net change of the function on the given interval over the change of x, or change of the variable, change of, let's say, x or t on the interval AB. So basically we find the ratio of the change of the function to the change of the independent variable. In other words, we have FB minus FA over, well, the change of x from AB is B minus A. Well, this has more information in it than just net change of the function. And that's why we have a name for that. We call it average rate of change of f on the interval a b. Average rate of change of a function on the interval a b. That's what is defined. So let me just put this one in the box. That's the first thing that we have. Okay. But sometimes you don't want to consider the time interval. You just want to see how the price of a house or temperature at this room changes. With what rate temperature of this room changes at this specific point. That's where we have we use average rate of change on an interval which is very close to that point, on, like, let's say x to a or a to x. Well, this is f of x minus f of a over x minus a. This is average, but I want to make it just what is happening at the point A. So that's where we find the limit of x goes to a. So when everything is happening very close to a, what is the rate of change of that function? Well, this quantity has a name, instantaneous rate of change of the function at the point A. Well, that's the second notion that today we learn here in this video. First one is average rate of change. The second one is instantaneous rate of change. By the way, so this is a good point to mention this thing, that if you don't see the word instantaneous, someone asks you what is rate of change of a function at a point, that means instantaneous rate of change. For average rate of change, you will always see the word average, but for an instantaneous rate of change, we drop that instantaneous, the word instantaneous. And well, you see the difference. Yes, for the average, we are having an interval, but for instantaneous rate of change or just rate of change, we need just 1 point. Okay, so let's do an example now here. See how this works. Okay, so consider the function x squared minus 3x plus 3 and find first average rate of change of the function on the interval 1, 4. Well, average rate of change of that function on that interval is f of right hand point minus left hand point, value of the function at right hand point minus value of the function at the left hand point minus right hand point minus over right hand point minus left hand point themselves. So here we need to compute what is f of 4. Well, 4 squared minus 3 times 4 plus 3 minus, what is f of 1? 1 squared minus 3 times 1 plus 3 over 4 minus 1. Okay, very nice. Here, this is 16 minus 12. This is 4. 4 plus 3 is 7. That's f of 4. Negative 3 and 3, they cancel each other and you get 1 there. And this is 3. So we have 6 over 3 and that is 2. So average rate of change of that function on the interval 1, 4 is 2. How about instantaneous rate of change of that function at the point 1? So remember what we do. First find average rate of change of the function on 1 to x. So this is what we have. Then find the limit of that as x approaches to 1. Let's see, what does this mean? Here, x goes to 1. What is f of x? Well, f of x is what we have there given minus f of 1. Actually, we computed it was 1. Yes, here. So that's minus f of 1. X minus 1. Let me just simplify. Just limit of x goes to 1 over x squared minus 3x plus 2, x minus 1. Well, we have quotient, use quotient law, but here is something right away you notice. The denominator is 0 as x goes to 1. The limit of the denominator is 0. So I cannot use quotient law. If that happens, we have to see what happens in the numerator. You see the limit of the numerator is also 0. So we have 0 over 0. And we have to get rid of the vanishing factor. X minus a here, x minus 1. Means that while we already have x minus 1 in the denominator, find the factor x minus 1 in the numerator and cancel them. Well, factorization of this guy is easy. 2 numbers which add up to negative 3, and when you multiply you get 2. So those are negative 1, negative 2. Now that you do the factorization, you can see that you can simplify the numerator, the denominator. This is x minus 2 over 1, and as x goes to 1, that is 1 minus 2, which is negative. And you see the meaning is a little bit different, well, a lot different. In an instantaneous case, we have a limit involved, but for the average rate of change, you just compute the quotient of, or the ratio of net change of f over change of x. Let me finish this video by one small remark. What is the relation between a slope of tangent line of, okay, let me just write slope versus a rate of change? Well, let's say we have the function f. This is the graph of that. Let's say a is somewhere here and b is somewhere here. And now let me just copy paste this guy here. Copy and paste. What you notice right away is that, okay, you see the points here. At point A, we have AFA. At point B, we have point BFB. Consider the straight line which passes through these 2 points. Well, that line, that straight line, will have a slope equal to FB minus FA over B minus A. But we know that this is average rate of F on the interval AB. So average rate of F on the interval AB is equal to the slope of the line passing through 2 endpoints of the graph of F on the interval AB. Very nice. So that's average rate of, so it is slope of a line. How about instantaneous rate of change? Well, that was limit of fx minus fa over x minus a as x approaches to a. Well, this guy here, if you look carefully, is the same thing as limit of f of x plus h minus f of a plus h minus f of a over h as h goes to 0. And that guy is nothing but the slope of the tangent line to graph of f at the point x equal to a. So that is where we have that. So both of these guys have a slope, meaning one is the slope of a secant line and the other one is the slope of tangent line to graph of that function. Okay, so we define what is rate of change, average, instantaneous. We did some examples and we mentioned what is the relation between the slope and rate of change of the function.